What is entropy? Entropy is one of the most fascinating and misunderstood concepts in science. It appears in physics, chemistry, information theory, and even discussions about time and the universe itself. At its core, entropy is a measure of disorder, uncertainty, or the number of possible ways a system can be arranged. To understand entropy, imagine a brand new deck of cards. When it's perfectly ordered by suit and number, the system has low entropy. Now shuffle the deck thoroughly. The cards are mixed in countless possible arrangements. This state has much higher entropy. The key idea is that there are far more disordered arrangements than ordered ones, which makes disorder statistically more likely. In physics, entropy is central to the second law of thermodynamics, which states that in an isolated system, entropy tends to increase over time. This law explains why heat flows from hot objects to cold ones, why ice melts instead of spontaneously forming, and why perpetual motion machines are impossible. Energy becomes more spread out and less useful as entropy increases. Entropy is also deeply connected to the arrow of time. While most fundamental physical laws work the same forward and backward in time, entropy does not. We remember the past, not the future, because the universe started in a state of extremely low entropy and has been increasing ever since. This one-way increase gives time its direction. Beyond physics, entropy plays a role in information theory. In this context, entropy measures uncertainty or the amount of information in a message. A completely predictable message has low entropy, while a random one contains high entropy. This idea is crucial in data compression, cryptography, and modern communication systems. Importantly, entropy does not mean that everything inevitably turns into chaos everywhere. Local order can increase, as in living organisms or technological systems, but only by increasing entropy elsewhere. Life itself survives by exporting entropy to its surroundings. In short, entropy explains why things fall apart, why time moves forward, and why the universe evolves the way it does. It is not just a law of physics, but a fundamental principle that shapes reality at every scale.